Aloha champions, and welcome back to this Wednesday social studies video. We're going to be talking about time zones. We've talked about the space between lines of latitude and longitude, using those to find exact coordinates and the exact location of specific spots in reference to our maps, using special keys and scales to interpret what our maps mean. Now we're going to understand time zones. So our big question for today is, how are time zones and Earth's rotation connected? If you remember back to third grade science when you talked about space, Earth is a round, spherical planet tilted on its axis, rotating constantly rotating and spinning around its axis. And how does that impact our time zones? Okay. So, Chapter 4, Time Zones, a puzzle about time. A family is traveling by ship from China east towards Los Angeles, California. The mother is about to have twin babies. At 1 a.m. on Monday, January 1st, 2001, the ship nears the 180-degree meridian, line of longitude. The woman has a baby girl. The ship then crosses the 180-degree line of latitude, and an hour later, the woman gives birth to a second girl. Baby 1's birth certificate says that she was born at 1 a.m. on Monday, January 1st, 2001. Baby 2's birth certificate says that she was born at 2 a.m. on Sunday, December 31st, 2000. So even though she was born an hour after her older sister, because of how they're traveling, her birth certificate says that she was born a whole day before her sister. The baby's father is confused. There must be an error on the birth certificate. How could baby 1, who came out first, have a later birth date than baby 2? Well, that's because they crossed what is known as the international date line, or that 180-degree line of longitude. The puzzle about the two children is easy to explain, relatively. You already know that geographers have drawn imaginary lines from the North Pole to the South Pole, or lines of longitude. One of these lines is at the 180-degree longitude. At this point, one day changes to another. If it is Monday on the east, it is still Sunday on the west. Here we have a ship traveling in the Pacific Ocean, presumably crossing that 180-degree international date line. Well, on the other side, it will be Tuesday on the west side. There is a difference in time of 24 hours, and we call this line the international date line. The international date line generally follows the 180-degree longitude by international agreement. The calendar day on the east is one day earlier than the calendar day on the west side of the line. The international date line is the same as the 180-degree meridian in most places. In some places, it curves around areas of land. This is so the line doesn't run through the middle of countries. People on one side of a street might be a day behind people on the other side, and that would be just confusing. So, to solve that problem, the international date line is placed over ocean. So if it ever crosses land, we alter the line to say, everybody on this side, you're on this date. Everybody on this side, you're on that date. Most people do not notice the international date line. It doesn't have much to do with our local events or local time. People traveling between Asia or Australia and the United States are the ones who are most affected by the international date line. People flying from Japan may arrive in the United States hours before they ever left. People flying from the United States will arrive in Japan a whole day later. They'll miss 24 hours by crossing that international date line. Of course, you don't grow older or younger by crossing the international date line. It takes roughly the same time to fly in both directions, about 12 hours there, 12 hours back, depending on who you fly with. The International Dateline was created to solve problems facing world travelers. To help you understand these problems, consider the story of one of history's greatest travelers, Ferdinand Magellan. Ferdinand Magellan was an explorer in the 1500s. He led the first voyage to circle the globe, or to circumnavigate the entire Earth, by sailing his boat. Magellan and his crew were the first to experience the problems that occurs when travelers go all the way around a rotating planet. Magellan and his crew, they sailed from Spain to the Americas, and they kept traveling west. Eventually, they had gone all the way around the world. Magellan himself did not finish the journey, unfortunately. He died along the way. His crew completed the voyage, and members of the crew kept careful records of their journey. And when they reached Spain again, they found that the journey had taken one more day than their records showed. Later, something similar happened to people traveling the opposite, east, around the world. They would arrive home a day earlier than they originally expected. In order to solve this problem, the International Dateline was created. It's not a perfect solution, however. Odd things can happen, as in the case of the twins born in reverse order. Still, you may be wondering, why did Magellan and other travelers seem to lose or gain days magically? Why was the International Dateline necessary? Well, it has something to do with time zones. And our time zones are one of 24 zones around Earth within which everyone observes the same time, more or less. There's a lot of interesting rules about time zones, such as Arizona, which doesn't obey the mountain time zone that we stay in because we don't observe daylight savings time, but that's a whole nother complicated mess of understanding. Time zones. The International Dateline is easier to understand if you first understand time zones. Other parts of the United States have different times than where we live. Perhaps you've seen on TV a program that begins at 8 p.m. on the East Coast begins at 7 p.m. in the Midwest, or Central Time. That same show then begins at 6 p.m. in the Rocky Mountains, or the Mountain Time Zone, and 5 p.m. on the West Coast. Viewers in all those places are watching the same show at the same time, but the clocks on their walls say very different times. The United States, including Alaska and Hawaii, has 6 time zones, and most states are in one of 4 time zones. When people travel through the time zones, they gain or lose time. For example, suppose you board a plane in Cleveland, Ohio, and this city is in the Eastern time zone. The plane flies to Chicago, Illinois, which is in the Central time zone, and the flight lasts about 1 hour. Well, if you leave at 1 p.m., you will arrive in Chicago at 1 p.m., almost as though no time has taken place, even though you know you sat in that seat on the plane for 1 full hour. Well, how is this possible? Well, places in the Central time zone are 1 hour earlier than places on the Eastern time zone. So even though you spent an hour flying, you gain the hour back by entering into this new mysterious time zone. So here's a map of the United States, color coordinated with approximately the time zone. So in orange, we have all of New England, and the southeast coast are in the Eastern time zone. So if it's 10 a.m. there, well, in the Central time zone, it would be 9 a.m. In the Mountain time zone, where Arizona happens to fall, it would be 8 a.m., unless daylight savings time then will be more aligned with Pacific time, but that's another issue. And then Pacific time is these 4 states on the west. Alaska has a time zone all of its own, and despite being almost the same size as 2/3 of the United States, everywhere in Alaska follows the same time zone. Hawaii has its own time zone because it's further west, I should say, into the Pacific Ocean. However, when you fly back from Chicago to Cleveland, you'll lose time. If you leave at 8 a.m., you'll arrive at 10 a.m., so that flight becomes 2 hours, even though it's only 1 physical hour of sitting in the seat on the airplane. You lose another hour because you change back time zones. Changes in time occur whenever you travel between time zones. If you travel into the next time zone to the east, you lose an hour. If you travel into the time zone to the west, you gain an hour. If you look at the map of world time zones on page 41, what time zone would we live in? What time would it be right now? What time would it be in Los Angeles, and what time would it be in New York? International time zones. The time zones in the United States are part of a worldwide system of time zones. There are a total of 24 time zones. Think of the time zones as making up a continuous circle that goes around the world from east to west. Each time zone is 1 hour apart from its neighboring time zones. Each time zone to the east is 1 hour later than the one to its west. Each time zone to the west is 1 hour earlier than the one to its east. The international dateline is in the middle of a time zone. The time on the east side of the time zone is 1 day earlier than the time on the west side of that time zone. Look at this map. Just to the east of the international dateline, it is midnight on Saturday. Just to the west of the international dateline, it would be midnight on Sunday. Now use what you've learned. If it is 4 a.m. on Tuesday in LA, on the west coast of the United States, what time would it be in New York? Okay, so here we have a map of time zones around the world. And while some areas, like here that touches part of Greenland and parts of Brazil and South America, that looks like a pretty straight line. You also got these weird curvy lines where it tries its best to stay in line in the ocean or to accommodate whole countries so that they're all on the same time. China has its own time zone that everybody in China adheres to. You also have parts of the world that have 30-minute increments instead of 1 hour increments between them. Here in the United States, we have our Eastern time zone, our Central time zone, our Mountain time zone, and our Pacific time zone. And if I count from the prime meridian, if it's noon in England, it would be, and I'm trying to figure out where it is in New York, I go over 1, 2, 3, 4, 5. I subtract 5 hours from noon, it would be 7 a.m. If I'm traveling from Los Angeles, where it is currently 4 a.m., travel over 1, 2, 3, 4, it would be 7 a.m. So 3 over, add 3 hours, it would be 7 a.m. Okay, our international dateline, as we said, tries to follow as best as it can the 180-degree line of meridian through the ocean. So around Russia, to include all of this easternmost province of Russia into the same date, down through here, zigging around some islands not to disrupt them. On this side of the line, it's Saturday. On this side of the line, it is Sunday. Okay? We have a few non-standard times located here in India, Sri Lanka, Bangladesh, parts of Iraq and Afghanistan, and parts of Australia that are not standard. They move half an hour increments instead of full hour. Okay? Well, what day would it be in Australia? The continent is across the international dateline from Alaska, therefore Australia is 1 day ahead of California. So if you started on Tuesday in California, it would be Wednesday between 8 and 10 p.m., depending on what part of Australia. But why do we have time zones? Why do we have such a confusing system? Well, why is such a complicated system of time zones created? Well, here's a clue. Earth is divided into 24 time zones, and what else is divided into 24 parts? Our day. Our days are split up into 24 parts. There's 24 hours in a day. Here in the United States, we like to use AM and PM to indicate 12-hour blocks of time, but you have 12 a.m. or midnight to 12 p.m., noon. That's one 12-hour block of time. Then you go from noon to midnight, add another 12 hours. There's 24 hours in a day. So if you set a day, you are on the right track. The 24 time zones on Earth and the 24 hours in a day are very closely connected. You see, Earth spins on its axis at a very steady rate. It completes a full rotation every 24 hours and a few minutes. This means that different areas of Earth are facing the sun at different times. When the U.S. and its time zones face the sun, they experience daytime. Meanwhile, China and its time zones are facing away from the zone and experiencing nighttime. Time zones were invented because of this rotation. If Earth didn't rotate on its axis, we wouldn't need time zones. But what about that international dateline? Why was it created? This is one of those cases where one thing led to another. First, the time zones were set up. Nice increments. This amount of lines of longitude represents this amount of time. The time zone in Greenwich, England became the one that all other time zones depended on. This caused a need for the dateline. You can understand this by looking at the map of world time zones. First, you find the prime meridian. This is at 0 degrees longitude. It runs through Greenwich, England. Imagine that it is 3 a.m. on Saturday, June 10th in Greenwich time zone. What time will it be in the next time zone to its east? Well, it will be 4 a.m., of course. Now count over 11 more time zones to the east. Adjust the time as you go. You should end up in a time zone that is shaded green that includes Eastern Russia and New Zealand. If you have counted correctly, you should say that the time in this zone is 3 p.m. on June 10th. And you may say, hey, that was easy, but there's just one small problem. What happens when you count on this time on the same time zone from the west, you'll get a different answer. Try it and see. So go back to Greenwich and count 12 time zones to the west. Adjust the time as you go. If it is 3 a.m. on Saturday, June 10th, in Greenwich, it would be 2 a.m. next time zone to the west. Then it will be 1 a.m., midnight, 11, and on the previous day, June 9th. Keep counting until you have ticked off 12 time zones. You should end up in the same time zone that you were in before. It is the green one containing Russia and New Zealand. But what are the date and time? According to this count, it's 3 p.m., just as it was before, but it's now Friday, June 9th, instead of Saturday, June 10th. So which day would it be in the time zone? Would it be June 9th or June 10th? Geographers figured that the only way to solve this problem was to divide this contested time zone into two parts. In the eastern half of the time zone, it would be the later date, and that's how the international dateline became. So if I go back to this map, and I start from my prime meridian in Greenwich Village, if I'm going to my east, I go 12 noon, 11 a.m., 10 a.m., 9 a.m., 8 a.m., 7 a.m., 6 a.m., 5 a.m., 4 a.m., 3 a.m., 2 a.m., 1 a.m., and midnight. Well, you see how the green zone is split in half? This side is still on Saturday. This side still is ahead on Sunday. Okay? So this international dateline separates the new day. So on Earth's rotation, these parts of Russia and New Zealand, they experience the new day first, while parts of Alaska and Hawaii and other Pacific Island nations are the last to change over to a new day. So if, say, on New Year's, you have this part of the world celebrates New Year's first, and then in 1 hour increments, they separate the changing over to a new year 1 hour at a time until we get to Arizona, which would be entering into a new year almost 18 hours after other parts of the world, just because we're trying to match the rotation of Earth and how we experience daylight and nighttime on different scales, so that everybody has relatively, that you wake up relatively around 6, 7 a.m. with the sun, go to bed relatively 7, 8 p.m. when the sun sets, because the Earth is rotating. So I know that's a lot of information. I know it may not be the easiest concept to grasp, But hopefully you found this somewhat fun and informative. You're going to take some time to answer 5 to 10 questions on Google Classroom about this reading. Thank you so much for your time. Stay awesome, and I will talk to you real soon.